everyone, welcome to Study Recnol, your space for easy and fun computer science learning. In this video, we are diving into the basics of Python programming, perfect for absolute beginners or anyone who wants a quick refresh. We will start with a quick introduction to Python, then move on to variables, data types, tuples, dictionaries, and sets, all explained in a clear and simple way. By the end of this video, you will have a solid foundation to start writing your own Python code confidently. So grab a notebook, maybe an iced coffee, and let's get started. And if you enjoy learning, let's rewind to the late 1980s. A Dutch programmer named Guido van Rossum was working at a research institute in the Netherlands called CWI, Centrum Wiskunde en Informatica. At that time, there were many programming languages, but most were either too complex or lacked flexibility for scripting. Guido wanted to create a language that was simple, readable, and easy to learn, something that even beginners could pick up without a steep learning curve. In December 1989, during his Christmas holidays, Guido started working on a new project, and by February 1991, he released the first version of Python, version 0.9.0. Now, here's a fun fact. The name Python isn't named after the snake. Guido was actually a fan of the British comedy group Monty Python's Flying Circus, so he chose the name Python to reflect something fun and approachable, just like the language itself. Over the years, Python kept evolving. Major versions like Python 2.0 come out in 2000 and Python 3.0 was released in 2008. Python 3 brought many improvements, but it was not backward compatible with Python 2, meaning old Python 2 code wouldn't work directly into Python 3. As of now, Python is maintained by the Python Software Foundation, and its latest versions support modern programming needs like data science, machine learning, web development, automation, and much more. Now that you know a bit about where Python came from, let's talk about why it's so popular today. Here are the top features of Python that make it stand out. Python has a very clean and readable syntax. You don't need curly braces or semicolons. Even beginners can write basic code and understand it without confusion. Python is completely free to download, use, and share. It's open source, which means developers around the world contribute to its growth. Python is an interpreted language, meaning code is executed line by line. You don't need to compile it, which helps in quick testing and debugging. Python lets you focus on what to do, not how to do it. You don't need to worry about memory management or system level stuff. It handles all that in the background. Write once, run anywhere. Python code can run on Windows, Mac OS, Linux, or any platform without changes, as long as Python is installed. You don't need to declare the type of a variable. Python figures it out automatically. Python has libraries for almost everything. NumPy for math, Pandas for data, TensorFlow for AI, Django for web development, and the list goes on. Got stuck? Just Google it. Python has a massive community, thousands of tutorials, and helpful forms like Stack Overflow and GitHub. Python is everywhere, used in web development, AI, and machine learning, data analysis, scripting, game development, and even robotics. So that's a quick overview of Python's origin and why it's such a big deal in today's tech world. From a simple Christmas project to one of the most loved programming language, Python is truly inspiring. To start using Python, we first need to install it on our system. Go to the official website python.org and download the latest version for your operating system. For Windows, open the installer and make sure to check the box that says Add Python to the path, then click Install Now. Once installed, open command prompt and type Python version to check if Python was successfully installed. On Mac OS, download the installer and follow the setup. For Linux, use the terminal commando sudo apt install python 3. After installation, you can start writing Python code right from the terminal or use an editor like VS Code. That's it. Python is now ready to use. Python syntax is one of the main reasons it's so popular, especially among beginners. It emphasizes readability and simplicity, making code look like plain English. One key feature of Python is indentation. Instead of using symbols like curly braces to make the beginning and end of code blocks, Python uses spaces or tabs. This makes the structure of the code clean and consistent. However, indentation is not just for style, it's required. Improper indentation can lead to errors. Another important rule is that Python statements usually end by simply going to the next line. There's no need to use a semicolon at the end of each line, although it's allowed. Python is also case sensitive. That means variable are all treated as different names. So it's important to be consistent when naming your functions, variables or classes. To define blocks of code such as loops, functions or conditionals, Python uses a colon at the end of the header line. This tells Python that the next indented lines are part of that block. In addition, Python allows you to write and execute code directly in an interactive mode, which helps in learning and testing small pieces of code quickly. Overall, Python syntax is designed to be clean, intuitive, and easy to follow, which makes it an ideal language for beginners and professionals alike. In Python, variables are like containers that hold data. You can store a number, a name, a decimal value, or even a whole list inside a variable. Python uses a very simple approach to create variables. You don't need to declare the data type. Just write the variable name. Use an equals sign and give it to a value. Python will automatically detect the type for you. This is called dynamic typing. Variable names should be meaningful and follow certain rules. They can start with a letter or an underscore, but not with a number. They can include letters, numbers and underscores, but spaces and special characters are not allowed. And remember, variable names are case sensitive, so data and capital D with the data are treated as two different variables. You can also assign values to multiple variables in one line, or you can assign the same value to several variables at once. This feature helps keeps your code short and clean. Another important point is that variables can be updated anytime. You can change their value or even assign a new data type later in the program. This flexibility makes Python very beginner friendly, but be careful not to name your variables with a reserved keywords or built-in functions like print or input, because that can cause unexpected errors in your program. To see what a variable holds, we usually use the print function to display it. In real-world coding, meaningful variable names make your programs more readable and easier to maintain. So to sum up, Python variables are simple to use, dynamically typed, and essential for storing and managing data in your programs. Now that we know how to use variables in Python, let's take a look at data types, the different kinds of data we can store in our variables. In Python, there are several built-in data types, and each one is used for different kind of information. First, we have integers. These are whole numbers, positive or negative, like 1, -3 or 1000. They are used when you need to work with numbers without decimals. Next, we have floating point numbers or simply floats. These are numbers with decimals like 3.14, -0.001 or 100.99. Floats are perfect when you need more precision in calculations, like working with measurements or financial data. Then there's the string data type. Strings store text, and in Python they are written inside either single or double quotes. You can store names, sentences or any kind of textual data in a string. We also have booleans. Booleans are simple data types that represent either true or false. They are often used for conditional statements and controlling the flow of the program. Python also supports lists, which are ordered collection of items. A list can hold different data types like integers, strings or even other lists. Lists are useful when you need to store a collection of items like a list of names or numbers. Tuples are similar to lists but are immutable, meaning their values cannot be changed after they are created. Tuples are enclosed in parentheses. Then there are dictionaries, which are key value pairs. Each item in a dictionary has a unique key that maps to a value. Dictionaries are incredibly powerful for storing data in a structured way, like storing the name and age of a person. Python also has sets. A set is an unordered collection of unique items. Sets are great when you need to store a group of items but don't care about the order, and duplicates aren't allowed. Finally, Python supports none, which is a special data type representing the absence of a value or a null value. To summarize, Python has a wide range of data types: integers for whole numbers, floats for decimals, strings for text, booleans for true or false values, and more complex types like lists, tuples, dictionaries, and sets. Each data type has its own purpose, and choosing the right one helps make your code efficient and easy to understand. Let's dive deeper into numbers in Python. Python supports two main types of numbers, integers and floating point numbers, but there's much more you can do with them. Integers. Integers or int type in Python are whole numbers that can be positive, negative, or zero. These numbers don't have any decimal places, and you can perform all sorts of mathematical operations on them, like addition, subtraction, multiplication, division, and even exponentiation. But Python's integers aren't just limited to small values, they can be arbitrarily large. Python doesn't have a fixed size for integers, unlike some other languages. This means you don't have to worry about overflow errors for big numbers. Next, we have floating point numbers or floats, which are numbers that include decimal points. You can perform all basic arithmetic on floats as well. And Python provides several functions to round them, like round, which rounds a float to the nearest integer or a specified number of decimal places. Also, when you divide two integers in Python, the result is always a float. For example, dividing 5 by 2 will give you 2.5, not 2. Python also supports scientific notation for large or small numbers. For example, 1e3 represents 100 and 1e minus 3 represents 0.001. Basic operations with numbers. You can easily add, subtract, multiply, and divide numbers. Python also supports advanced operations like modulus, which gives you the remainder of a division, and exponentiation, which calculates powers. For instance, double asterisk gives you 8. Python also provides built-in functions to check the type of a number, such as type of 4 for an integer and type of 4.5 for a float. Strings in Python. Now let's talk about strings, sequence of characters that are used to represent text. In Python, strings are incredibly versatile, and you will use them constantly in your programs. Creating strings. Strings can be created by enclosing text in either single quotes or double quotes. Both work the same way. For example, single quotations hello and double quotes hello are both valid strings. You can also create multi-line strings using triple quotes like this is a string and this is another string. These are especially useful for long pieces of text or doc strings. String operations. Python offers various operations to manipulate strings. You can concatenate strings by using the plus operator, or repeat a string using the asterisk operator. For example, hello plus world gives you hello world. Strings are immutable in Python, which means once a string is created, you cannot change its content. However, you can slice a string to extract a specific part of it. String slicing is done using the colon operator. String methods. Python provides several built-in methods for string manipulation. Lower converts the string to lowercase. Upper function converts the string to uppercase. Strip function removes any leading or trailing white space. Replace of old, new replaces all occurrences of a substring with another substring. Split splits a string into a list of words based on delimiter. You can check the length of a string using the len function, and you can check if a string contains a certain substring using the in keyword. String formatting. Python allows for easy string formatting using f strings. You can embed variables inside strings by simply writing them within curly braces inside the string, prefixed with an f. For example, f double quote hello of curly braces within name would insert the value of the name variable into the string. You can also use the format method to achieve similar results in older versions of Python, though f strings are recommended for their simplicity and readability. Working with numbers and strings together, at times you will need to combine numbers and strings. Since Python is strongly typed, you can't just add a number and a string directly. To this, you need to convert the number into a string using the str function. So to summarize, integers and floats are the main types of numbers in Python, used for whole numbers and decimals respectively. Strings are used for text, and Python offers many methods for manipulating them. Strings are immutable and numbers can be modified or combined using arithmetic operations. Now that we have covered numbers and strings in depth, you are well equipped to handle basic data types in Python and start writing powerful programs. Let's explore the Boolean data type in Python, which is one of the simplest yet most important types when it comes to logic and decision making in your programs. The Boolean type can only have two possible values, true or false. Boolean values are used to represent truth values and are the foundation of conditional statements like if and while loops, and they play a critical role in controlling the flow of your code. True and false values. In Python, the Boolean type is represented by true and false. Notice that these are capitalized, unlike many other languages where Booleans might be represented as 1 and 0. Python specifically uses true and false as keywords. For example, true represents a logical truth, false represents a logical falsehood. Booleans are most commonly used in expressions that compare two values. These expressions return a Boolean value, either true or false. Depending on the condition being checked, you will typically see Boolean expressions used in comparison operators like equal to, not equal to, greater than or equal to, less than or equal to. Python supports logical operators that combine multiple Boolean expressions. These operators are AND, returns true if both conditions are true, OR, returns true if at least one condition is true, NOT, inverts the Boolean value if it's true, NOT make it false, and vice versa. Boolean context. In Python, any non-zero number is considered true and 0 is considered false. The same rule applies to non-empty containers like lists, tuples, and strings. They are considered true, while empty containers are considered false. Here's a quick guide. Numbers. 0 is false, all other numbers are true. Strings. An empty string is false, while any non-empty string is true. List. An empty list is false, while a list with any item is true. None. The value none is also considered false. This is helpful when using Booleans to check if a variable or container is empty or has a value. The Boolean type is most commonly used in conditional statements to decide the flow of execution. For instance, in an if statement, the condition is evaluated, and if the expression is true, the block of the code inside the if is executed. Python provides a built-in function called bool that can be used to convert values to Boolean. It takes a single argument and returns either true or false. This can be useful when you want to explicitly check if a variable has a truthy or falsy value. To sum up, the Boolean data type is fundamental to logic in Python. It represents true and false values and is used to control the flow of your program. You can combine Boolean expressions with comparison operators and logical operators to create complex decision-making logic. Understanding how to use Boolean values effectively and allows you to make decisions and direct the flow of your code, ensuring your program behaves the way you intend. In Python, one of the most powerful and commonly used data types is the list. A list is an ordered, mutable collection that can hold multiple items of the same or different data types, all in a single variable. Think of a list like a container or a shopping bag where you can keep items like numbers, strings, or even other lists. To create a list, we use square brackets. Each item inside is separated by a comma. For example, you can create a list of numbers, names, or even mix them together. Lists can store integers, strings, floats, booleans, and even other lists. The ability to store mixed data types is one of the reasons Python lists are so flexible. Each item in a list has an index. Python uses zero-based indexing, which means the first element has an index of 0, the second is 1, and so on. You can access items using these indexes inside square brackets. You can also use negative indexing. The index -1 gives you the last item in the list, -2 gives you the second last, and so on. Python allows slicing, which means extracting a portion of the list. You can do this using the colon syntax. The start index is inclusive, the end index is exclusive. You can even add a step value like list start end step to skip elements. Slicing gives you a powerful way to work with subsets of data. Python lists are mutable, which means you can change their contents after they are created. You can update an item using its index, append a new item to the end using append function, insert an item at specific position using insert function, remove items using .remove function, .pop function, or delete. The .pop method also returns the item it removes, and del can be used to delete items or even entire lists. Common list methods. Python offers several built-in methods to make working with lists easier. Append of item adds an item to the end. Insert of index, item adds an item at specific position. Remove of item removes the first occurrence of the item. Pop of index removes and returns an item by index. If no index is given, it removes the last item. Index of item returns the index of first occurrence. Count of item counts how many times an item appears. Sort sorts the list in ascending order. Reverse function reverses the order of elements. Clear function removes all elements from the list. All of these methods make it super easy to manage collections of data in your program. You can loop through lists using a for loop. This allows you to perform an action on every item one by one. You can also use the range and length functions to loop over list index if you need to access the index and value together. For more advanced cases, the built-in enumerate function is very handy if you use both the index and the item at the same time. Nested lists. Python lists can also contain other lists as elements. These are called nested lists. Think of them like a grid or a matrix, useful for representing structured data like tables or board games. To access items in nested lists, you can use multiple indices. Copying lists. It's important to know that assigning one list to another creates a reference, not a copy. To create a real copy, you can use list.copy function. This prevents accidental changes to both lists when only one is modified. To recap, lists are ordered, mutable, and can store mixed data types. They support powerful operations like indexing, slicing, updating, and looping. Python provides many useful built-in methods to manipulate list data. You can even create nested lists and use list comprehensions for compact logic. A set is a built-in data type used to store multiple unique values. It's unordered, unindexed, and automatically removes duplicates. To create a set, we use curly braces or the set function. For example, even if you write the same item multiple times, only one copy will be stored. Since sets are unordered, they don't support indexing or slicing. You can't access elements by position like you would in a list. Sets are mutable, meaning you can change them after they are created. One of the biggest strengths of sets is their support for mathematical set operations: union, intersection, difference, symmetric difference. Checking if an item exists in a set is fast using the in keyword. For example, apple in my set. This is the one reason sets are great for performance when working with large data sets. If you need an immutable set, Python offers frozen set. It's like a regular set, but once created, you can't modify it. Useful when you want to use a set as a dictionary key or store it in another set. To summarize, sets are unordered, unindexed, and store unique elements. They support fast membership checking and powerful operations like union, intersection, and difference. Use frozen set for immutable collection. Sets are simple but powerful, perfect when you need to handle unique data efficiently. In Python, a dictionary is a built-in data type used to store key value pairs. It's like a real-life dictionary where you look up a word, the key, to find its meaning, the value. Dictionaries are unordered before Python 3.7, mutable, and do not allow duplicate keys. Each key in a dictionary must be unique and immutable. Like a string, number, or tuple, you create a dictionary using curly braces with a colon, separating each key and its values. Keys and values are paired like this: key, value, and each pair is separated by a comma. Accessing and modifying data. You can access a value by using its key inside square brackets. For example, square brackets of name gives you the value stored under the key name. To add or update a value, just assign a new value to the key. If the key exists, it updates the value. If not, it adds a new key value pair. Python provides powerful built-in methods to work with dictionaries: get of key, keys, values, items, pop of key, update functions. These methods make it easy to manage and interact with your data. Dictionaries are ideal when you want to associate pieces of related data, like storing a student's names with their marks or a country with its capital. They also allow fast lookups by key, making them great for building databases, configuration of files, and more. To sum up, dictionaries store data in key value pairs. They are unordered, mutable, and keys must be unique and immutable. You can easily add, update, or remove items. They are efficient, flexible, and heavily used in real-world Python programs. So, if you want to link values to unique identifiers, dictionaries are the go-to data type in Python. In Python, typecasting, also known as type conversion, refers to converting a value from one data type to another. It's a fundamental concept that allows variables and expressions of one type to be transformed into another so that they can be used in a different context. For example, converting a string to an integer for mathematical operations. There are two types of typecasting in Python: implicit and explicit. Implicit typecasting. This is when Python automatically converts one data type to another during an operation. It usually happens when a smaller or less complex type is involved in an operation with a larger or more complex type. For example, when adding an integer and a float, Python converts the integer to a float to avoid loss of data. This type of conversion happens behind the scenes, so the programmer doesn't need to write any special code. Why it's useful? Implicit casting ensures smoother operation and helps avoid type errors in expression that mix types. Python only does implicit casting when it's safe. It won't try to convert a string to a number automatically, as that could lead to an unexpected behavior. Explicit typecasting. Explicit typecasting is when the programmer manually converts a data type using built-in Python functions. These include int, float, string, bool, list, tuple, set, dictionaries. This is especially important when handling user input, which is always received as a string, file data or API responses, which may not be in the right type, mathematical operations where types must match. Converting between collections. Python also allows converting between different functions. These conversions are useful in tasks like removing duplicates, ensuring immutability, or reformatting data. Typecasting risks. Be careful. Trying to convert ABC to int will cause a value error. Casting a float to int will truncate the decimal part. Converting collections without compatible data formats will raise errors, so always check the type and content of data before casting, especially in user-facing applications. To sum up, explicit typecasting is done by Python automatically when safe. Explicit typecasting uses functions like int, float, and string. You can also convert between collections like lists, tuples, sets, and dictionaries. Typecasting is essential in data handling, especially when working with inputs, files, or APIs. Always validate your data before casting to avoid runtime errors. Mastering typecasting helps make your code cleaner, safer, and more efficient. In Python, handling input and output is a key part of creating interactive programs. Let's break down how input and output work in Python. Output in Python. Python provides a built-in function called print function to display output. This can include text or strings, numbers, variables, or even expressions. By default, print ends the output with a new line character, meaning that after each print function, the cursor moves to the next line. But Python allows us to customize this behavior using optional arguments. The separate argument specifies the separator between multiple values printed. By default, it's a space. The end argument specifies what to print at the end. By default, it's a new line, but you can set it to something else like an empty string. Input in Python. For getting input from the user, Python uses the input function. When called, it passes the program and waits for the user to type something. The entered value is always returned as a string, and even if the user types a number. If you need perform calculations with the input, you will have to convert it into the appropriate type using functions like int or float. Why input and output matter? Input and output make your programs interactive. They let you accept user data and display results based on that data. Without input, your programs would be static, and without output, users wouldn't know what the program is doing. Together, they enable you to create programs that are responsive to the user's need. Print is used for output in Python. Input is used for taking user input, always written in a string. Input must be covered if you want to perform calculations or use it in a different data type. Both are essential for creating dynamic interactive programs. With input and output, your programs can engage with the user, making them more flexible and useful. That's it for today's video. You have learned some fundamental concepts of Python, from its history and features to how we handle input and output. If you found this video helpful, make sure to like, comment and subscribe for more tutorials. Let me know in the comments what you want to learn next, and I will be happy to help. Thanks for watching and happy coding.